Hi Math to Enhance. This is pages 5 and 6 in our packet, and we're going to be learning how to factor our polynomials. So we're going to learn how to factor our polynomials. So sometimes we can factor our polynomials by simply factoring out a GCF. Please scratch out the word for, that's just a typo. So this is an example of factoring out a polynomial with just the GCF. So in this problem, I look at my three terms and I notice they all have a 3x in common. So I'm going to factor out a 3x. So when I do this and I divide the first term by 3x, I get x squared. When you are factoring out, it's like division. And x cubed divided by x to the first, when you're dividing like bases, we subtract exponents. You can think of it as x times x times x divided by a single x, and a single x cancels. I have an x squared left over. And then 3x squared, negative 3x squared divided by positive 3x gives me a negative x, and negative 6x divided by a positive 3x gives me a negative 2, and my x's cancel. Now I might be done here, but x squared minus x minus 2 actually factors. So I have to continue factoring until it's in its most factored form. So going back to our last unit, I would put my a times c at the top, which is negative 2, my b at the bottom, which is negative 1. And then I'm thinking of my factors 1 and 2 on the sides, where if my 2 was negative, they multiply to negative 2 and they add to negative 1. So since my a is 1, I can just stick those into my parentheses, and I get that it's 3x times x plus 1 times x minus 2. This problem did not ask me to solve it, so I can be done here. That would be my polynomial in its most factored form. So let's continue by looking at some that I'm going to factor with grouping. So take a moment and pause this video and read the words above example 1 when it's talking about factoring by grouping, please. Welcome back. So hopefully you remember factoring by grouping from our last unit. So looking at example 1, there's no greatest common factor. So I'm going to start this by doing factor by grouping on my 4 terms. So in my first 2 terms, I notice that they have a x squared, oops, I don't know why I put that there. I notice I have an x squared in common, which leaves me with an x plus 3 in the parentheses. In the second 2 terms, I notice that I have a negative 4 in common, which also leaves me with an x plus 3 in parentheses. So my same parentheses is x plus 3, so you can write these in either order. And my leftovers is x squared minus 4. But I am not done. This is the difference of 2 squares, dots from our first unit. So I have to keep factoring because x squared minus 4 is not in its most factored form. So I would get my x plus 3 times, and then x squared minus 4 factors into x minus 2 and x plus 2. If you need some help with that, please come see me. So this would be my answer for the factored form of my polynomial. This is in its most factored form. And if you'll notice in the directions, after factoring, it says then to find the zeros. These are my roots. This is when I set it equal to 0 and I solve. So I'm going to set this equal to 0, and that means I'm going to set each factor equal to 0 to find out what makes it 0. And so in this case, I have x plus 3 equal to 0, or x minus 2 equals 0, or x plus 2 equals 0. And I'm getting x equals negative 3, or x equals 2, or x equals negative 2 as my roots, as my solutions. So I have 3 real roots here. They are real roots because I can actually physically graph them on the x-axis, and I could graph my polynomial. Non-real roots would be something that would have an I in it. So let's look at something like that. So in this next problem, I have the same situation. There's no GCF, so I'm going to use my factor by grouping. Let me change my red pen to factor. And so out of the first 2 terms, it looks like I'm going to pull out an x squared and have an x plus 2 left. My next 2 terms, it looks like I'm going to pull out a 9 and also have an x plus 2 left. So I'm going to get my same parentheses is x plus 2. My leftovers is x squared plus 9. So this is in its most factored form. X squared plus 9 is not the difference of two squares because it's plus. So there's nothing else to do. It's done. So now I'm going to, so that's factored. So now I'm going to solve this. I'm going to set my factored form equal to 0. And I'm going to solve each one of these by setting them equal to 0. So either x plus 2 equals 0 or x squared plus 9 equals 0. So this gives me x equals negative 2. This is one real root. This is actually a number I can plot on my x-axis. It's a real number. It's a real root. However, when I solve this, I get x squared equals, let's subtract 9 from both sides. And now I'm going to take the square root of both sides, and I get x equals and plus minus. The square root of 9 is 3, and the square root of negative 1 is I, so I get 3i. This is really two answers. You are welcome to write it like this. In fact, on my answer key, this is how I wrote it. But this is really two answers. It's x equals a positive 3i, and it's also x equals a negative 3i. So it's really two non-real roots for a total of 3 roots for this cubic third degree equation. One real root of negative 2 and two non-real roots of plus or minus 3i. So why don't you take a look at this next problem. My factor by grouping, if it works, notice I said if, I would pull out my GCF. So in this problem, I would get an x squared, and I get a 2x minus 1 left over. My next one, I have a 2 in common, and I get an x plus 1. This is where I want you to stop. This is a real type of problem. I haven't given you anything like this before. But stop. Because my parentheses do not match, my parentheses are not the same, and I did not make a mistake. They're just not the same. This one is not factorable by grouping. So this is a problem that I'm going to use in my next section, Unit B, Lesson 3. I'm going to use the rational root theorem. I'm going to abbreviate it here. This is going to be Unit B, Lesson 3. This is a problem, since I can't solve it by factoring, I'm going to need another method, and that method is the rational root theorem, and we're going to learn that in the next lesson. So problems like this will pop up in the next lesson. So now example 4 has a greatest common factor. My greatest common factor is negative 3. I don't have to factor it out, but all of my math becomes more clear and less difficult when I do take out my GCFs. So let's go ahead and do that. Let's take a moment and factor out my negative 3. And when I do that, I get a positive x cubed. Well, I love having a positive first term, hence why I factor out a negative 3. And I get a negative 2x squared, and I get a positive 5x, and I get a negative 10. So now I'd like you to pause the video, and I'd like you to completely factor this, and then turn the video back on and see if you factored it okay. Welcome back. So compare our answers. Notice these brackets I used here. We used those in the last unit, in Unit 1, our quadratics, when I had a GCF on the outside, just to kind of keep it separate from my factor by grouping work. So this would be my factored form. This is the answer if I was to factor this polynomial. Now I'd like you to pause the video, and I want you to solve it and see if we get the same answers for our roots. How did we do? So notice I don't do anything with the negative 3. There's no x with it. So the negative 3 is not part of my zeros. You know what the negative 3 is telling me? It tells me this parabola points the opposite direction, negative. Not parabola, sorry, this is going to be a cubic function. So this negative tells me it's going to fall from the left down to the right. And it also tells me that it's going to be more narrow because of the 3. My y values are all getting multiplied by a 3, but it doesn't tell me anything about my roots. So I set the x minus 2 equal to 0 to get x equals 2. This is my one real root for this problem. I could have 3 real roots, or I have to have 3 total roots because this is a cubic polynomial. This is the highest degree of 3. So if I'm going to have any non-real roots, they always come in pairs because of the plus minus. So my plus minus I square root of 5, this is my 2 non-real roots for my total of 3 roots total. Awesome. So this is my next style. It's quadratic style. And what do we mean by that? Well, this basically means that I'm going to have a trinomial. So it's a oops, sorry, I didn't have it set up right. So this is when my polynomial looks like a trinomial or even a binomial that can be factored the same way I was factoring our quadratic equations in the last unit. So for example, I'm going to have the same 3 terms, but instead of being an x squared and an x, it might be an x to the 4th and an x squared, which works the exact same way. We'll look at that in a moment. Or instead of having the difference of 2 squares, I could have like an a to the 4th minus a b to the 4th, and that would work the same way as the difference of 2 squares do. So let's take a look at some of this. In this first one, I want you to notice it has 3 terms, so it's a trinomial. And I'm going to see if it's factorable by using my diamond method. My negative 5 goes at the top. That's my a times c. 1 times negative 5. My negative 4 goes on the bottom. And I think about this, and I realize that when I factor it, I get a 5 and a 1, and my 5 is negative. So careful here. The difference with this problem is that now in my parentheses, I don't have an x. I have an x squared. Well, why is that there? Well, I have an x squared because when I multiply these together with FOIL, I need my first term to be x to the 4th. So in this problem, my a was 1, so I don't need factor by grouping. So I know the negative 5 and the plus 1 goes into my parentheses. So let me do that now. Negative 5 and plus 1. Now I'm going to erase this in a moment, but I just want to FOIL this to show you guys how I get back those terms. Now I'm going to FOIL this, so I'm going to do an x squared times x squared. That's my x to the 4th. Remember, I add the exponents when I'm multiplying like bases. I get a negative 5x squared. I get a plus 1x squared, and then I get negative 5 times a positive 1 or a negative 5. So when I combine my like terms, I get x to the 4th minus 4x squared minus 5. This is the same problem I had before. This factored just like my quadratic problems factored, but I had to remember in my parentheses to put my x squared. So let me erase this because I actually need this room to do the problem. So then this is my answer for when it asked me to factor. And now I'm going to find my zeros. I'm going to find my roots. So I'm going to set 0 equal to my equation. Notice the x squared minus 5. It doesn't factor anymore. It's not the difference of 2 squares. 5 is not a perfect square. And x squared plus 1 didn't factor anymore because it's not the difference. So I was done. So now I'm going to solve it. Notice I should expect to get 4 answers for I should get 4 roots because this is a 4th degree polynomial. So x squared minus 5 is either equal to 0 or x squared plus 1 is equal to 0. And when I add 5 over, I get x squared equals 5. And when I take the square root of both sides, I get x equals plus or minus the square root of 5, which is a number. It's a real number. It's around 2.2. So this is telling me negative 2.2 and positive 2.2 are 2 of my roots. So this is giving me two real roots. However, when I subtract 1, I get x squared equals a negative 1. So now when I do my square root of both sides, I get x equals, and the square root of 1 is 1, and the square root of negative 1, or a negative, is I. So this is just going to be I plus or minus I. So this is my 2 non-real roots. 2 non-real roots for a total of 4 roots for this 4th degree polynomial. So example 6, does this mean I'm going to get 5 roots? It does. I'm going to get 5 answers for number 6. It's a lot of fun. So let's get started. First of all, you're going to have to look for this on your own in your homework quizzes and tests, but there is a GCF here, and my work becomes so much easier and clearer if I take out my GCF. So 6, 51, and 27 all have a 3 in common, and x to the 5th, x cubed, and x all have an x in common. So I'm going to factor out of this a 3x. When I do that, in my parentheses, I'm getting a 2x to the 4th minus 17x squared minus 9. This now is my quadratic style I was just talking about. This has 3 terms. It's a trinomial. So I'm going to see if this factors. It may not. Maybe it's really a problem for the next lesson, the rational root theorem. So my AC goes on top. It's been a while. This is my negative 18. I'm going to add the x to the 4th so you guys can see it. That's my A times C. And on the bottom, that's my negative 17, and that was really an x squared. So my side numbers really have x squareds with them, so that they multiply to negative 18x to the 4th, and they add to negative 17x squared. We didn't used to put those in, but I think when you first start seeing x to the 4th and x squared, it can be confusing. I'm using them the same way I used to use x squared and x. It's quadratic style, but now it's to a 4th degree polynomial. So now I'm thinking of my numbers that go on the sides, and I'm pretty sure it's 18 and 1, and I think the 18 has to be negative. So since my A is 2, I'm going to have to use factor by grouping here. So I still have my 3x on the outside, but this is now where I'm going to use brackets, because now I have to do a whole factor by grouping problem. I'm going to keep my 2x to the 4th. Instead of writing negative 17x squared, I'm going to write my minus 18x squared. I'm going to write my plus 1x squared. You don't have to write the 1 there. And I'm going to write my minus 9. So I still have my 3x out in front, but now I need to do my factor by grouping. So I underline the first 2 and the last 2. And I notice in the first 2 I have a 2x squared in common. So that gives me x squared minus, what is this going to be, 9? And in the second one, I don't have a GCF in common. So I'm going to just take out a 1. A positive 1 will be fine, because then I get an x squared minus 9 in my parentheses. And so now I can write this as 3x, my GCF. My same parentheses is x squared minus 9. And my leftovers is 2x squared plus 1. So as far as factoring it, you are not done. If you have to completely factor this, there is one more step. Now, if your goal is to solve it, you can ignore this step. So what do I mean? If this problem asked you to write this in the most factored form, and I'm going to erase this line, but you would have to continue one more time, because x squared minus 9 is not most factored. This is the difference of 2 squares. This is my nice friendly dots. It's really x minus 3 and x plus 3. And then I have my 2x squared plus 1. This would be my most factored form for an answer. You would have to do that if you were being asked to leave your answer in factored form. Now, if you're being asked to solve it, like find the zeros, you actually don't have to do this step, because you can solve x squared minus 9 and you get the same 2 answers, 3 and negative 3. So this step isn't absolutely necessary. It's completely up to you. So I know that if I'm going to set this equal to 0, then each of my factors must be equal to 0. So first of all, if 3x equals 0, then I know x could be 0. That is one real root. If x minus 3 equals 0, then I know x could be 3. That's another real root. If x plus 3 is equal to 0, then I know x could be negative 3, which is what I was trying to say earlier. If you set x squared minus 9 equal to 0, you would get 3 and negative 3. So if you're just solving it, you could skip that last dot step, and it doesn't affect your problem. And so now I have my 2x squared plus 1 equal to 0. I'm going to subtract 1 over. 2x squared equals negative 1. divide both sides by 2. X squared equals negative 1/2. And now I'm going to take the square root of both sides. And this means that x would be the square root of my negative 1/2. And so the square root of a negative is I. And the square root of 1/2, I'm just going to leave underneath here. It's a number. It's an imaginary number. And I need my plus minus since I took a square root. So this is my 3 real roots over here. And my plus minus give me my 2 non-real. These are my imaginary roots. 2 non-real roots for a total of 5 roots for this 5th degree equation. So this next problem, I'm going to ask you to pause the video and try it on your own. First of all, this is a GCF problem. And then it's not actually quadratic style. It's going to be factor by grouping. So pause this video and try it yourself and then come back and see how you did. Welcome back. Let's take a look at how you did with this problem. Let's first look at the factored form in red. So I pulled out a GCF of 2x, and then I realized I had 4 terms. So if I have 4 terms, my only thing to try is factor by grouping to see if it works. And it won't always work, but if it's factorable, it will. So it does. I got same in my parentheses as 2x minus 5, and my leftovers were x squared minus 2. And so now I set each one of my factors equal to 0, and I get 4 answers because this is a 4th degree polynomial, so I should have 4 answers, and they're all real answers. These are all real roots. This is 4 real roots. I get 0, 5 halves, and then the square root of 2 is a actual number that I could graph on the x-axis. Plus 1.41 and minus 1.41. Those are my 4 real numbers that are my answers there. So if you were taking your notes at home, I did split these notes over 2 class periods because, as you can tell, they take a while. So this last section does use the sum and difference of 2 cubes. You were introduced to this in Unit 1, but we didn't do a lot with it. So I'd like you to pause this video for a moment and read through these steps. It says here are the steps required. We've already done these steps, and so I want you to read through and remind yourself and come back to the video. So welcome back. So first of all, in order to solve this, we're going to have to factor it. Let me show you a mistake kids sometimes make. I'm going to erase this. Sometimes smart kids write x cubed plus 8 equal to 0, x cubed equals negative 8. They're going to then try to cubed root both sides. And when they do that, they get x equals, there is a cubed root of 8. The cubed root of negative 8 is actually a negative 2. But the problem with that answer is that I only have 1 answer there. And this is a cubic polynomial. I'm supposed to be getting 3 roots. Negative 2 is one of my roots. It's a real root, but I actually have 2 non-real roots as well, and I don't get them when I set up my equation this way. So if you were thinking about that, I like how you're thinking a lot, but that's not how I can solve this one. So let's go ahead and set this equal to 0, and we'll get busy. We're going to factor it first. So I think I'm going to write my 0 on this side, just make it easier. So x cubed plus 8 is the sum of 2 cubes. So the cubed root of x cubed is x, and the cubed root of 8 is 2. So I'm going to set this up with the pattern of my sum of 2 cubes. And so in my first parentheses, I'm going to have the x and my 2. I'm going to have what I see, which is the sum. It was the sum of 2 cubes. In my second set of parentheses, I'm going to have the square of my first, which is x squared. I'm going to have the square of my second, which is the 4. And in the middle, I have their product. So that would be 2x in this case. And my signs, remember, it's right what you see in the first one. So this was x cubed plus 8. So I wrote a plus sign in my first set of parentheses. And then the second parentheses is different. This is the same, different, and end on a positive. That's a I think another term for that, some kids use SOAP. Same, opposite, always, always positive. Same idea as that right there. So this is completely factored. You could try to do the diamond with x squared minus 2x plus 4, but there's no side numbers that work. So this is completely factored. You're done if you're factoring. But if I'm solving, I'm going to set each factor equal to 0, and I'm going to solve. So I get x equals negative 2 again. We got that last time. This is my one real root. And then x squared minus 2x plus 4, since it does not factor, I either have to use complete the square or I have to use quadratic formula. And I know a lot of you favor the quadratic formula, and that's fine. You're welcome to use it. I'm going to complete the square, mainly because my a is 1 and my b is even. So for me, completing the square goes more quickly than quadratic formula. So on this problem, you can pause the video and do it with, or fast forward if you want to use the quadratic formula instead. But to do completing the square, I have to move my 4 over and leave a space. So I get x squared minus 2x, leave a space, equals negative 4, leave a space. My next step is to complete the square. That's when I do my b divided by 2 and square it. So negative 2 divided by 2 and square it. I get negative 1 squared, or 1. This is the number I add to both sides because I'm trying to complete the square. So I have to add it to the left. And whatever I do the left side, I want to make sure I do the right side. And then this factors, this is a perfect square trinomial that factors into the square root of the first, the square root of the third, and the sign from the middle. And then that equals negative 3. So now I'm going to take the square root of both sides, and this gives me x minus 1 equals plus or minus, and the square root of the negative is I, and the square root of the 3 stays. So I'm almost done. I need to add my 1 over. I'm going to put it right in front of my plus minus, so I'm going to add 1 to both sides to get 1 plus or minus I rad 3. This is my other 2 roots. This is my 2 non-real roots for a total of 3 roots for my cubic third degree equation. So I need all 3 of those in my answer. So let's take a look at the next one. The next one is, I'm going to write over here a little bit. So I have my 2x cubed minus 54 equals 0. We already talked about how I don't want to just add 54, divide by 2, take the cubed root. I'm only going to get my real root. I'm not going to get my other 2 roots. So I don't want to do that. I'm only going to get 1 root if I do that. So I want to factor this in order to find all my roots. So I notice I have a GCF, so I'm going to take out that 2. And when I do that, I get x cubed minus 27. And once I do that, I can see that I have the difference of 2 cubes. So I'm going to continue factoring. My difference of 2 cubes in the first parentheses is the cubed roots. So in this case, the cubed root of x cubed is x, and the cubed root of 27 is 3. So I get x and 3. And in my second set of parentheses, this is where I write the square of my first one, which is x squared, the square of my second one, which is 9, and then their product, which is 3x. And my signs, I get to write what I see. So my first parenthesis matches my x cubed minus 27. It's a minus. And my second set of parentheses are going to be different. So that's positive, and then always positive. So now that I've done this, this is what I'm going to solve. The 2 equals 0 doesn't make any sense here. So I don't do anything with the 2. It just means that this guy is more narrow. So I'm going to set the x minus 3 equal to 0, and I get x equals 3. That's a real root, 1 real root. And then I'm going to look at the x squared plus 3x plus 9 equal to 0. Now, this problem doesn't factor, and it's not a great candidate for completing the square because I have a 3 for my b. So I would get a 3/2 squaring it. So I'd get fractions. You can do it with completing the square, but it's a little better for quadratic formula. So here we go. My a is 1, my b is 3, and my c is 9. So in this, I'm going to get my x equals negative 3 plus or minus the square root of 9 minus 4 times 1 times 9 all over 2 times 3, or I'm sorry, 2 times 1. And I get x equals negative 3 plus or minus This is 9 minus what, 36, all over 2. So I'm getting negative 3 plus or minus 9 minus 36 is negative 27, all over 2. I can simplify this. I could certainly pull out the I. I'm not sure how precise we're going to get with simplifying square roots in this unit because it's not really what we're covering. But I'm definitely going to pull out the I, and my 27 is 9 times 3. So I could do the square root of the 9 and get 3. And on the inside, I would have just my leftover 3, all over 2. But really, actually, I'd like you guys to write it, and I'm going to go ahead and do it just to save room on my paper. You're going to write both of them, each of them, over their own 2. Since this is a complex number with a real part in front, that's my negative 3 halves, my negative 1.5, plus or minus 3i times the square root of 3 all divided by 2. This is 2 non-real roots. So these are 2 non-real roots. And this is my 1 real root. For 3 total roots for this cubic equation. Thank you so much.